Today, I want to share about how you can leverage Imagery for planning, asset management, and operational efficiency. Today, I'd like to begin by showing you this Ag Explorer. It is a specialized tool powered by ArcGIS Comprehensive Imagery and Management System. It's an example of a centralized, easy-to-use platform for crop monitoring, health analysis, and predictive insights using Sentinel-2 imagery. Here, we are looking at the different tools such as layers, measurement tool, base map, image renderers, date selector, and tools to analyze NDVI values in harvesting year, season for analysis. The Sentinel-2 has been corrected for atmospheric effects, providing a more consistent reflectance values, making it more accurate for agricultural analysis. I will be using this agricultural renderer, which is highly sensitive to vegetation health and chlorophyll content. Let us look at this interesting part of Sumatra, an agriculture powerhouse in Indonesia. I want to examine this area, which is ideal for monitoring plantation health and land use changes. On the screen, I've changed the cloud coverage to 40% and selected an imagery from July. This image has low cloud coverage, allowing us to get a clear view of plantation activity and surrounding landscape. As we can see here, green vegetation typically reflects strongly in the near-infrared, which makes healthy crops appear bright green, just like what we're seeing here today. Another thing I want to do is compare the imagery with an earlier capture from July 2020. I will be using the swipe tool to visually inspect the differences between the two dates . And we can see that these reddish portions are still planted or still have crops in 2020. And without being physically present in the area, we can deduce a few things based on remote sensing. The shift from bright green to reddish brown suggests that this area has been harvested, showing reduced chlorophyll content, causing a shift to brownish tones. Now I want to extract the NDVI profile in 2024 to better understand the growth cycle and health of this plantation. This bright green plantation, which appears to be in a healthy state. To get more precise data, I'll digitize the crop boundary directly within this platform. You can make some meaningful observations and extrapolations by focusing on how NDVI changes align with the biological stages of all palm growth over 1 year. And the great thing about this system is that imagery is being processed directly via the web, which means we are able to access and analyze historical data almost instantly. This field shows high and stable NDVI values throughout 2024, indicating healthy vegetation and consistent growth. Now let us digitize the second field. Here, we can see that the second field has lower and more variable NDVI values, suggesting crop stress or harvesting. The dips in the profile could also reflect nutrient deficiency, water stress, or seasonal harvesting cycles. But for this case, the plantation has been harvested. The contrast highlights how NDVI helps identify growth patterns, stress events, and harvesting periods, enabling better management and improved productivity. This year, we continue to focus on ways that Esri tools can help us achieve greater operational efficiency. Building on that, I am very excited to share with you what ArcGIS Comprehensive Imagery and 3D System is. Today, we have more sources of imagery and other remotely sensed data than ever before. And the ArcGIS Comprehensive Imagery and 3D System supports all aspects of imagery life cycle, from capture all the way through exploitation and imagery-derived insights. Looking into it a bit more closely, you as an organization may be working with crewed aircraft, drones, satellites, and even MMS or your mobiles and CCTVs to acquire imageries of your sites, cities, or countries. And with ArcGIS Comprehensive Imagery and 3D System, we provide a solution to tap into all this data. This is the ArcGIS Comprehensive Imagery and Remote Sensing, a scalable solution that seamlessly integrates imagery from beginning to end. Organizations that are using imagery to support reality mapping can create accurate site models, base maps, and other 3D foundational content. We also provide tools to analyze imagery to detect spatial patterns that helps you understand the natural and built environment. We have tools to visualize imagery to enable human interpretation and extract information for use cases like inspections, monitoring, and intelligence. And this imagery comes into all kinds of formats from multiple platforms, modalities, from many service providers, and you need a system that lets you manage, search for, and discover and analyze all your imagery to support the workflows across your organization. The imagery management capabilities of ArcGIS are designed to bring all of this data together. ArcGIS is the system for managing all your imagery. It provides photogrammetry, GeoAI, and raster analysis that supports different use cases. Let us look at the comprehensive imagery and 3D system empowering the imagery management. What our imagery management does is first organize your imagery and remotely sensed data, help you make them accessible to the people who need it within your organization, and visualize and analyze it to help you answer questions. We provide flexible deployment options to meet the customers in where they are at their imagery journey. ArcGIS Image provides 4 deployment options for a wide range of imagery capabilities. Listed here are the different products and key features available with the 4 deployments. So no matter what the size and scale of your organization, ArcGIS is there to meet your needs securely and reliably. Now let's take a look at how you can do image management using ArcGIS. This is an example of a content management dashboard demonstrating an effective way of managing your geospatial data, including geospatial imagery. By publishing a catalog dataset, we can have a great deal of insights about the organization's assets, including count of each type, storage they consume, and different layer types. I am particularly interested for an image service published in 2024. And this image service is over Colorado. I can simply type the name of the area I'm looking for, And with that, I can open the scene viewer very easily through the web. Through this content management dashboard, I can easily access the dataset that I need and start the work that I need to do. Another powerful data model that we have is the Mosaic dataset. It is actually used to manage multiple images over time. In this area, we have multiple images collected in different dates. The Mosaic dataset can be time-enabled to represent when each of the images over one area have been collected. In this example, I can open a time slider, and as I move it, images changes depending on the time periods and image collection, such as 2019, 2020, 2023. And that's a very powerful capability of the Mosaic dataset. And managing imagery with Mosaic dataset makes it easier for you to serve this out to other users within your organization. You can share this Mosaic dataset as a web layer so your colleagues within your department or within your organization can access those imagery. Another way is via the Create Imagery hosted layer. You can choose the imagery layer that you need and set the data sources and define other parameters. And this basically allows you to share all these images you manage centrally to be shared in a standard format and can be accessed by people in your organization. Now let's talk about reality mapping and oriented imagery. Reality mapping is the process of creating accurate digital representation of the physical world using images, LiDAR, or both. You can create true ortho, DSM, point cloud, and 3D mesh with images coming from your drone, satellite, or aerial. ArcGIS also has the oriented imagery capability. The oriented imagery offers an end-to-end workflow for managing, sharing, and visualizing a wide range of imagery types. You can manage your images and metadata using an oriented imagery dataset, which can be from drones in ArcGIS Pro or use ArcGIS Quick Capture for images taken with cell phone or mobile devices. You can publish oriented imagery to ArcGIS Online or Enterprise and then use ArcGIS Instant Apps to create and share oriented imagery web apps. Lastly, you can visualize and explore your imagery using the oriented imagery viewer. And this is built into Pro, Map Viewer, ArcGIS Excalibur, Sidebar Instant App template, or you can add it to a custom web app. We are continuously improving. We have added many new features for ArcGIS Online and ArcGIS Pro 3.3. Now let's take a look at some example of this oriented imagery. We understand that field data collection is an important activity in your organization. So ArcGIS streamlines the collection of field data and sharing to stakeholders. This map shows the location of reported observation at a solar site. And each observation contains information of what was observed and geotagged image collected by field workers using native apps in their mobile devices. Users of the web app can access all of these oriented imageries and view each image in the same perspective as the field worker that captures it. So this allows users to remotely assess and inspect assets without having to be physically out in the field. Here is an example of an oriented imagery catalog over a water treatment plant. What you see here is a base map overlaid with green polygons which represent the oriented imagery coverage over this area. These green polygons outline the field of view of the captured images, showing exactly where each image has taken and what it covers. Now, I've just opened the oriented imagery viewer, and as I click on any area with the oriented imagery, a video or an image will pop out, and I can start exploring the oblique views or video perspective captured over time. So this allows me to see the site from different angles, offering more than just a top-down view. Now, let us take a look at reality mapping in action. This is a drone project we have set up using ArcGIS Reality for ArcGIS Pro. From this, you can see the camera positions represented in yellow, the flight path in orange, and the image footprints in green. And as I open the Reality Mapping tab, I can see the different products that I can produce using these drone images. I can produce multiple products such as True Ortho, DSM, Point Cloud, and 3D Mesh. Here is a very detailed True Ortho produced by Reality, and really showcasing the intricacies of the details of the tanks, pipes, and other assets in this area. And with this highly accurate True Ortho, you can easily add your other GIS, providing more context in this reality mapping products, really creating a comprehensive facilities and operational visual digital twin. Now we will be looking at the 3D Mesh, all produced fully automatically using ArcGIS Reality. This foundational content for our digital twin really gives that capability for us to fully explore this site without any physical restrictions. I can see all of my assets and activities precisely as the day the drone have flown, and can monitor some activities and review projects that have concluded. You can also do some in-depth inspection, such as check the roof for rust corrosion, and even check some roof damage. Lastly, you can also do volumetrics and 3D measurements and fuse other information into your 3D mesh. This is the beautiful Red Rocks Amphitheater in Colorado. Using a drone, this imagery was captured and then processed with ArcGIS Reality, fully automatically creating this stunning 3D mesh. The reality mapping products are GIS ready And the beauty of this is that many of you are building 3D systems of records that you can update using this accessible technology so you can see how things change and capture that into your 3D GIS. Now let's talk about image analysis. ArcGIS enables powerful image analysis to extract valuable insights from geospatial data. And ArcGIS supports various data types like rasters, point clouds, elevation, oriented imagery, and multidimensional raster dataset, ensuring comprehensive analysis. It also includes tools for change detection, terrain analysis, GeoAI for machine learning and deep learning. And insights coming from imagery can be shared through dashboards, reports, story maps, and other custom applications, enabling data-driven decisions. One of the ways we help our customers be successful in GeoAI is by creating and making accessible pre-trained models that suit different business needs and applications. Customers can immediately start using them, and they don't have to do all the hard work of collecting training data, having the required compute resources, or even extensive AI knowledge. At this point, there are over 70 pre-trained models for many tasks, many of which you can see here, but you can add your own training data to fine-tune them to your specific geography and imagery. Now let's take a look at some of the image analysis in action. Here is an example of a deep learning model to detect objects using text prompts. In this case, I've instructed the software to identify all airplanes using our open object detector. ArcGIS detects objects and represents them with bounding boxes as shown on the screen. And these bounding boxes are then used as prompts for Segment Anything model, which generates masks for the objects. And these masks are converted into polygons and returned as GIS features. So with this workflow, users can detect and analyze objects of interest such as vehicles, ships, solar panels, or swimming pools using a simple text prompt, powerful and versatile for various applications. I'd like to showcase this one example of how GeoAI and remote sensing can automate palm tree detection and land cover classification. The first image shows palm trees detected using GeoAI, with each tree outlined in red, helping to calculate tree density and detect gaps for replanting. The second image is a land cover classification map where different colors represent distinct land types such as vegetation, water bodies, urban areas, and bare soil. And now we have seen how you can leverage imagery for planning, asset management, and operational efficiency, particularly in content, accessing vast collections of authoritative and ready-to-use imagery, apps and tools, management, leverage robust tools for managing and creating your own imagery data, new imagery type to gain value from your oriented imagery, reality mapping to create reality mapping products from drones, aerial, satellite, and analysis and visualization to apply scalable analytics to your image data from ArcGIS Pro to SaaS or from your enterprise. To conclude, I'd like to take one final look at the comprehensive ArcGIS imagery and 3D system that we've explored today. As you've seen throughout this session, the ArcGIS imagery system supports every stage of imagery lifecycle, from imagery capture to analysis and visualization. It's a powerful system designed to help you unlock the full potential of your imagery. Thank you all for your attention.